Mars has been staring at us for thousands of years. Ancient Egyptians called it her Disher, the Red One. Babylonian astronomers tracked its wandering path across the sky and named it after their god of death and plague. The Romans looked up, saw that blood-red glow, and named it after their god of war. Every civilization that ever looked up at the night sky noticed Mars. Something about it felt different, felt close, felt almost alive. They weren't entirely wrong. This is the story of Mars, told through 35 facts that, taken together, paint a picture of the most fascinating, most terrifying, and most familiar world beyond our own. A world that may have once been just like ours. A world that lost everything. And a world that, whether we're ready or not, humanity is heading to next. Let's start at the beginning. Mars is the fourth planet from the Sun, sitting about 140 million miles away on average, though that distance changes dramatically as both planets orbit. At its closest, Mars is only 34 million miles from Earth. At its farthest, it's over 250 million miles away. That gap matters enormously if you're trying to send a spacecraft there, or bring one home. A Martian day, called a sol, is 24 hours and 37 minutes long, almost exactly the same as an Earth day. When scientists and engineers at NASA plan rover operations on Mars, they actually live on Mars time, shifting their sleep schedules by 37 minutes every single day. After a few months, they're completely out of sync with everyone else on Earth. Some wear special watches that only show Martian time. A Martian year, however, is nearly twice as long as ours, 687 Earth days. Mars takes its time. These details might seem like dry statistics, but hold on to them, because they mean that if you were standing on Mars, your days would feel eerily familiar, but your years would stretch on and on. The seasons would be long and slow, and the winters would be brutal. Mars has the largest volcano in the entire solar system. Olympus Mons stands nearly 72,000 feet tall, almost 3 times the height of Mount Everest. Its base is so wide it would cover the entire state of Arizona, and its peak reaches so high that it punches above most of the Martian atmosphere. Standing at the base, you wouldn't even be able to see the summit. The curvature of Mars itself would hide it from view. Right next to Olympus Mons lies a canyon system that makes the Grand Canyon look like a scratch. Valles Marineris stretches over 2,500 miles long, 120 miles wide in places, and plunges nearly 23,000 feet deep. For comparison, the Grand Canyon is 277 miles long and about a mile deep. Valles Marineris is not a canyon carved by a river. Scientists believe it formed as the Martian crust cracked and pulled apart. A massive geological scar that has sat frozen in time for billions of years. Mars has 2 moons, Phobos and Deimos, but they're nothing like our moon. They're small, lumpy, potato-shaped rocks, almost certainly captured asteroids. Phobos is only 14 miles across and orbits so close to Mars that it completes a full orbit in just 7 hours and 39 minutes. It rises in the west and sets in the east, the opposite of every other moon in the solar system. And it's getting closer to Mars every year, spiraling inward at about 6 feet per century. In roughly 50 million years, Phobos will either crash into Mars or be torn apart by gravity into a ring. Mars is slowly eating its own moon. Now here's where the story takes a turn, because Mars isn't just a world of extreme geography. It's a world with a past that looks disturbingly familiar. Mars once had a magnetic field, a global magnetic field like Earth's, that would have protected its atmosphere from the relentless bombardment of solar wind. We know this because ancient Martian rocks detected by orbiting spacecraft are magnetized, frozen records of a magnetic field that once wrapped the entire planet. Then, around 4 billion years ago, something happened. The Martian core cooled and solidified. The magnetic field collapsed. And without that invisible shield, the solar wind, that constant stream of charged particles blasting out from the sun, began stripping away the Martian atmosphere, molecule by molecule, year by year, century by century. Today, the Martian atmosphere is about 100 times thinner than Earth's. It's composed of 95% carbon dioxide, The atmospheric pressure on the surface of Mars is less than 1% of what you'd feel standing at sea level on Earth. If you stepped outside on Mars without a spacesuit, the air pressure alone would kill you within minutes. Your blood would literally begin to boil. But here's the haunting part. Before all of that happened, Mars was wet. Mars has ancient river valleys, dried lake beds, and mineral deposits that only form in the presence of liquid water. Some of these valleys are enormous, carved by floods so large they would dwarf anything in Earth's geology. Mars has ancient river valleys, dried lake beds, and mineral deposits that only form in the presence of liquid water. Some of these valleys are enormous, carved by floods so large they would dwarf anything in Earth's geological record. Mars didn't just have puddles, it had rivers, oceans, perhaps a vast northern sea covering a third of the planet. NASA's Mars Reconnaissance Orbiter found evidence of recurring dark streaks that appear and fade on Martian hillsides with the seasons. For years, scientists thought this might be liquid, salty water seeping through the soil. The debate is still ongoing, but the possibility alone is extraordinary. The Curiosity rover found ancient lake sediments in Gale Crater, fine-grained mudstone that could only have formed at the bottom of a calm, long-standing lake. Not a flash flood, a lake. Billions of years ago, Gale Crater held standing water for potentially millions of years. Mars was once, by every geological measure, a habitable world. So what happened to all that water? Some of it is still there, locked in the polar ice caps. Mars has permanent ice caps at both poles, composed of a mixture of water ice and dry ice, frozen carbon dioxide. The northern polar cap alone contains enough water ice that, if melted, it could cover the entire planet in a shallow ocean about 36 feet deep. Water ice has also been found just beneath the Martian surface at mid-latitudes, not just at the poles. NASA's radar instruments have detected massive subsurface ice deposits covering areas the size of California and Texas combined. Mars is not a dry world. It is a frozen one. In 2018, the Mars Express spacecraft detected what appeared to be a subglacial lake beneath the southern polar ice cap. Liquid water kept from freezing by the pressure of the ice above, and likely by dissolved salts. A lake under the ice. On Mars. Right now. If that lake exists, and the debate among scientists is fierce, it is the single most significant discovery in the history of planetary science. Because where there is liquid water, on Earth, there is almost always life. Which brings us to the question that nobody wants to say out loud, but everyone is thinking. Mars has methane. Seasonal fluctuating plumes of methane have been detected in the Martian atmosphere by both the Curiosity rover and orbiting spacecraft. On Earth, the vast majority of atmospheric methane comes from one source: living things, microbes, wetlands, livestock. Of course, methane can also come from geological processes, volcanic activity, certain chemical reactions. But Mars is not volcanically active. Nobody has found the geological source. The methane is real. Its origin is unknown. The Viking landers sent to Mars in 1976 performed biology experiments directly on Martian soil. One experiment, the labeled release experiment, produced a positive result. The soil appeared to consume nutrients and release gases in a way that looked biological. The lead scientist on that experiment spent the rest of his career arguing that Viking had found life on Mars. NASA officially concluded the result was likely chemical, not biological. The debate has never been fully resolved. Certain meteorites found on Earth originated on Mars, blasted off the surface by ancient asteroid impacts, and eventually captured by Earth's gravity. One of them, discovered in Antarctica in 1984, caused a scientific earthquake in 1996 when NASA scientists announced it contained possible microscopic fossils, tiny tube-like structures that resembled bacteria. President Clinton gave a press conference about it. Scientists have argued about it ever since. No consensus has ever been reached. The evidence is never definitive. The question never goes away. Let's step away from ancient history for a moment and talk about what Mars looks like right now, because this world is anything but dead. Mars experiences global dust storms, the largest in the solar system. Every few Martian years, a regional dust storm grows and grows until it eventually engulfs the entire planet. The sky turns a deep, rusty orange. Sunlight drops to a fraction of normal levels. These storms can last for months. In 2018, one of those global dust storms rolled across Mars and killed NASA's Opportunity rover. Opportunity had been operating for 14 years, nearly 60 times its planned 90-day mission. It had driven over 28 miles across the Martian surface, sent back over 200,000 images, and survived 11 Martian winters. When the dust storm hit, its solar panels were blanketed and its batteries died. NASA's last message to Opportunity was a song, Billie Holiday's "I'll Be Seeing You." They sent it into the dark, 100 million miles away, to a dead rover on a silent planet. But before Opportunity went silent, it had already confirmed one of Mars' biggest secrets. The planet's surface is rich in hematite, an iron oxide mineral that on Earth forms almost exclusively in the presence of liquid water. Opportunity called these deposits blueberries. Tiny spherical hematite concretions scattered across the Martian soil like ball bearings. Water, again, always water. The Martian soil is more than just iron-rich dust. It contains perchlorates, highly reactive chemical compounds that would be toxic to most life as we know it. Perchlorates are the reason some scientists push back on the possibility of surface life on Mars. They are also, paradoxically, the reason some scientists think life could survive there, because certain microbes on Earth actually eat perchlorates for energy. Mars has two distinct hemispheres that look almost nothing like each other. The southern hemisphere is ancient, heavily cratered, and sits several kilometers higher than the north. The northern hemisphere is younger, smoother, and lower, possibly because it was once covered by a shallow ocean. The boundary between these two hemispheres is one of the sharpest geological transitions anywhere in the solar system. Nobody fully understands why. Temperatures on Mars swing wildly. At the equator on a summer afternoon, surface temperatures can reach a relatively mild 70 degrees Fahrenheit. But at night, those same locations plunge to -100 degrees. At the poles in winter, temperatures drop to -195 degrees Fahrenheit. Mars has seasons, and those seasons are extreme. Now let's talk about what happens when we show up. Because we've been sending our machines to Mars for decades, and Mars has not always been welcoming. Roughly half of all missions to Mars have failed. Spacecraft have been lost in transit, crashed on landing, gone silent without explanation, and in at least one famous case, crashed because one engineering team was using metric units and another was using imperial. The Mars Climate Orbiter, a $327 million spacecraft, was destroyed in 1999 because of a unit conversion error. Mars has a reputation. The first successful Mars lander, Viking 1, touched down on July 20th, 1976, exactly 7 years to the day after Apollo 11 landed on the moon. NASA had planned the landing for July 4th, American Independence Day, but the originally chosen site looked too rocky. They delayed, kept searching, and landed 3 weeks later. Sometimes caution saves the mission. The Mars Pathfinder mission in 1997 delivered a small rover called Sojourner, the size of a microwave oven, and it captivated the world. It was the first rover to operate on another planet. It drove a total of about 330 feet. People watched its slow, cautious progress on the early internet, and NASA's servers crashed from the traffic. A microwave oven on Mars broke the internet. Then came Spirit and Opportunity in 2004, each the size of a golf cart planned for 90 days. Spirit operated for 6 years before getting stuck in soft sand and going silent. Opportunity lasted 14. Between them, they rewrote our understanding of Martian geology and confirmed beyond any reasonable doubt that Mars had a wet, potentially habitable past. Curiosity, which landed in 2012, is the size of a car. It used a never-before-tested landing system, a sky crane, where a hovering rocket platform lowered the rover on cables to the surface. NASA engineers called the landing sequence 7 minutes of terror because the entire automated sequence had to work perfectly in order with no human intervention possible. It worked. Perseverance, the most advanced rover ever built, landed in February 2021. It carried something extraordinary, A small helicopter named Ingenuity. On April 19, 2021, Ingenuity lifted off the Martian surface, becoming the first powered, controlled flight on another planet. The Wright brothers' first flight lasted 12 seconds. Ingenuity's first flight lasted 39.1 seconds. NASA engineers placed a small piece of fabric from the original Wright flyer aboard Ingenuity before launch. History echoing across worlds. Perseverance has been collecting Martian rock samples and sealing them in small titanium tubes, leaving them on the surface for a future mission to retrieve and bring back to Earth. If those samples make it back, and the mission is planned for the early 2030s, it will be the first time material from another planet has been brought to Earth for analysis. Whatever is in those tubes could answer the question that has haunted science for a century. Mars has auroras. But unlike Earth's auroras, which are concentrated at the poles where the magnetic field is strongest, Martian auroras appear all over the planet, scattered and diffuse, remnants of ancient crustal magnetism. They're invisible to the human eye, appearing in ultraviolet light. But they're there, flickering across the Martian sky, ghosts of the magnetic field that once protected this world. The sound of Mars has been recorded. Perseverance carries 2 microphones, and they have captured the thin, eerie sound of Martian wind. Sound travels differently on Mars. The thin, cold atmosphere means high-pitched sounds barely carry at all. If you stood on Mars and someone shouted at you from across a room, you'd hear only the low, muffled rumble of their voice. The high frequencies would vanish entirely. Everything sounds deeper, more distant, more alone. The color of the Martian sky is not what most people picture. At dawn and dusk, the sky near the sun glows a pale blue, the exact opposite of Earth, where our blue sky turns orange and red at the horizon. On Mars, the fine iron dust scatters light differently. Blue sunsets on an orange world. And one day, possibly within our lifetimes, a human being will stand on that orange soil, look up at the blue sunset, and breathe recycled air inside a helmet and feel the 0.38 gravity pulling at their boots, and look back across 100 million miles of empty space at a pale blue dot in the sky, and know that that dot is home. Here's what 35 facts about Mars actually add up to. A world that was born alongside ours 4.5 billion years ago, from the same cloud of gas and dust. A world that had oceans and rivers and a sky, and maybe, just maybe, something living in it. A world that lost its magnetic shield, lost its atmosphere, lost its warmth, and slowly froze into the silent, rust-colored wasteland we see today. Mars is a cautionary tale. It is what happens when a planet loses the thin, fragile layer of protection that makes life possible. It is, in some very uncomfortable ways, a mirror. Earth has a magnetic field. Earth has an atmosphere. Earth has liquid water and moderate temperatures, and the precise, improbable conditions that let something as strange as life persist and evolve and eventually look up at the sky and ask questions. Mars had all of that once. We know this because we went and looked. And now we're going back. With better rovers, with helicopters, with sample return missions, and eventually with people. Not because Mars is easy. It is one of the most hostile environments imaginable. Not because it's close. It is months away at best. But because it holds answers that we cannot get anywhere else. Answers to questions about how planets live and die. About where life comes from, about whether we are alone, and maybe, just maybe, when the first astronaut bends down and picks up a handful of that ancient red soil, they'll find something in it that changes everything we thought we knew. Mars has been waiting 4 billion years. We're almost there. If this got your mind spinning, drop a comment. I want to know which fact hit you hardest. And if you want more deep dives like this, subscribe. There are a lot more worlds out there worth exploring. I'll see you in the next one.